All right, hi guys. We're looking at our next section of special right triangles. Last time we looked at 30, 60, 90 degrees right triangles. Now we're going to look at another way to find the missing sides if you only have one, with a different set of special angles, which is the 45, 45, 90 degrees for your triangle this time. Now, like last time for 30, 60, 90 degrees, your pattern was the x square root 3 and 2x for your different legs and your hypotenuse. This time, because you've got two angles that are the same, that means you've got two legs that are the same as well. So if we have two congruent angles, we get two congruent sides. And in this case, our sides are the legs. So we get two congruent legs, making this triangle isosceles. Okay, so this triangle is isosceles. So when we look at the pattern like we did last time, we don't have the same x root 3, and 2x. This time we have two legs that are the same. And then our hypotenuse is that leg times square root 2. So we're going to see how that works today with our new type of special right triangle. So I'm just moving this over a little bit. Okay, so looking at our triangle, all right, we have our 90 degrees. Oops, I'm going to make that just a little bit bigger. Okay, so we have our right angle. And again, across from that is always the hypotenuse. And again, our two legs are exactly the same length. They are not a short leg and a long leg. They are just a leg. Because they are equal, we don't need to know which one is the short or the long. So this time we've got just two formulas to work with because our legs are the same length. So if I need the hypotenuse, that is equal to your leg it doesn't matter which leg, times the square root of 2. And then if I need to get back to the leg, if I have a hypotenuse, and again, it doesn't matter which leg because they're the same, then that is your hypotenuse divided by the square root of 2. So let's see what happens with our examples. Now, this is a continuation of the 30, 60, 90, hence why we're starting with example 9, because the first 8 were for 30, 60, 90s. All right, so let's start with example 9. And I'm going to make these, may have to make this a little smaller, but we'll see. All right, so we have our two congruent legs. So our leg and a leg. So right now I automatically know that B is 2 because the legs are the same here. This is isosceles. So then the other two equal angles are my 45s. Across from the 90 is the hypotenuse. And so my formula for hypotenuse says take the leg, multiply by square root 2. And again, if my leg is a 2, then my A value is 2 square root 2. And like before, we're done. We're not taking that to a decimal. 2 square root 2 is my final. It's already in simplified radical form there. Let's try another one with example 10. All right, so you've got your 245. So my leftovers got to be the 90. Making the 9 square root 2 my hypotenuse. The other two have got to be my congruent legs because they're across from the 45s. So again, if I need the leg, that is your hypotenuse divided by square root 2. And again, if my hypotenuse is 9 square root 2, then we're really looking at 9 square root 2 divided by a square root 2. And like before, those radicals will cancel out. And my missing leg, which was x, is just the 9. And it's done. So again, this is very similar to the 30, 60, 90s, but let's try some more. Again, we have our legs. They're always across from the 45s for this kind of triangle. You have the hypotenuse. So my x is equal to the leg times square root 2. My leg this time is an 8. So x is 8 times square root 2, and it's done. Okay, then it's done because it is already in simplified radical form. All right, let's try 12, example 12, working backwards this time because we need the leg. Across from 90 is the hypotenuse. So my leg is equal to hypotenuse divided by square root 2. So x is equal to 3 square root 2 divided by another square root 2. Those radicals will cancel. And all that's left over to be my leg length is the 3. Again, it's done. We don't have to do anything else to this. Let's try some more. All right. Again, across from 90 is the hypotenuse. So that means 4 is my leg. So then my x is equal to the leg times square root 2. My leg had a length of 4. So my x is 4 square root 2. And it's done. Again, we're not taking this to any decimal. All right, 14 is a little different. Again, across from the 90 is the hypotenuse. This time our hypotenuse does not have a square root 2 in it, and there's nothing wrong with that. But the other two have got to be your legs. Notice they're both an x, so it doesn't matter which one we solve for. So again, my leg is the hypotenuse. Divide by square root 2. And my hypotenuse is an 18. So then my x is 18 divide by square root 2. And again, in algebra 2, you would have talked about rationalizing this denominator because generally we don't want to leave a square root in the bottom of our fractions like that. But for our purposes today, we are leaving it as is, 18 divided by square root 2. There's nothing more we're going to do to it. It stays how it looks. All right, we've got another one. Just like the last one, my hypotenuse across from the 90, this time it's a 16 instead of an 18. So my leg is supposed to be the hypotenuse divided by square root 2. So if my hypotenuse is 16, then my x is 16 divided by square root 2, and it is done for our purposes. All right, just a little bit more to go. All right, let's check out this next one. Again, across from the 90, we have the hypotenuse. We need the leg, so my x is supposed to be hypotenuse divided by square root 2. So my hypotenuse is 24 square root 2. So then 24 square root 2 divided by a square root of 2. The radicals cancel. We're just left with 24. All right. So let's try now a word problem and see what we need here. We've got two word problems down here, both with a 45, 45, 90. So 17 says if a 45 degrees, 90 degrees triangle has a hypotenuse length of 12, find the leg length. So best thing to do, draw your triangle. Any kind of triangle you want. But again, it is a 45, 45, 90. Across from whatever corner you put that 90 in, that's your hypotenuse. And we need to find the leg length. And again, it doesn't matter which leg because they are in fact the same. And it says the hypotenuse is 12. So again, our leg is the hypotenuse divided by square root 2. My hypotenuse is 12. So my missing answer, my X or L, leg, whichever one you want to call it, 12 square root, 12 over square root of 2. It's done. Let's try another one. Find the length of the hypotenuse of the 45, 45, 90 with a leg length of 14. So they're saying the 14 is the leg. We need the hypotenuse. So I'm going to try this one just using the formula and not writing out the picture. So again, our hypotenuse is the leg times square root 2. And they told me what my leg is. So my leg is the 14. So then my hypotenuse, 14 times square root of 2, and it's done. Now, just some reminders from some shapes that you actually worked with in middle school that do involve 45, 45, 90 degree triangles, just to remind everybody of some of these basic shapes. The square is a shape that does contain 45, 45, 90 triangles. So just keep in mind from middle school, squares have all 90 degrees. And if you were to draw that diagonal, it does cut those 90s in half and makes two 45s. And the same would be true if that diagonal was going the other direction. So again, just remember, a square is always made up of two 45, 45, 90 degree triangles, and all the sides are the same. Okay, so again, you're going to see some problems like this that uses the square as opposed to coming out and saying that you have a 45, 45, 90 triangle. So just some things I want you guys to keep in mind when you're working with squares. Again, you get two 45, 45, 90 triangles in every square, depending on how that diagonal is drawn. All right, guys, so I hope you enjoyed learning a little bit about your 45, 45, 90 special right triangles. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.